Hi, today we're going to be talking about RMS. RMS stands for root mean squared, and it's an important quantity that we need to be aware of whenever we are interested in calculating the power that an AC source delivers. For instance, we can have a circuit. In this case, I'm representing the circuit with a black box. So it's the same circuit in both cases. Yeah? And I can decide to power it with an AC source or with a DC source. Yeah? So for instance, if we decide to power it, let's say with 5 volts here, we will have, the circuit will draw a particular total current, and the power dissipated by the circuit or delivered by the source will be 5 volts times the total current. If we are interested in powering this circuit so that the same power is dissipated as in the DC source case, we need to put 5 volts RMS. So that here, my circuit draws a current of a particular total current, also RMS, and my power would be 5 volts RMS times the total current RMS. And because both circuits are powered with 5 volts, in this case 5 volts DC, and in this case 5 volts RMS, both circuits dissipate the same power. And that is the physical significance of the RMS power. So a 5 volts RMS source will deliver the same power to a given circuit as a 5 volts DC source. And that's why we need to know what the RMS is, so that we can calculate the power accordingly. Now, the RMS, as I mentioned before, stands for root mean squared, and the general formula for us to be able to calculate the RMS of a particular source, let's call our voltage source, in this case V of t, will be the VRMS of this particular voltage source, will be the root of the mean over one period of the squared of my signal. So this is the general equation, and the tricky bit about this is that the RMS is dependent on the shape of our signal. So usually we have a signal, we can take it from our power outlet, from our socket, that looks like this, like a sine wave. That's usually how our signals look like. But it's not necessarily always the case. Sometimes my signal might look different. My signal might come out of a rectifier, so that my signal's rectified like this. Or it might be a completely different signal, like, for instance, a sawtooth signal, like this. And in each case, the RMS value of these 3 signals will be different because they have 3 different shapes. And so therefore, we need to know how to calculate, in general, the RMS of an arbitrary signal. And that's what we're going to be looking at in the next couple of videos. So thanks for watching.